Alright, on this problem, still in section 2.5, we are asked to solve a system of equations using a matrix equation. So my first step is to turn this system of equations into a matrix equation. So first I'm going to have what's called a coefficient matrix, which means I'm taking all the numbers that are in front of x and y in this case, and putting them in a square matrix. So here I've got 4x, negative 1y, that's from my first equation, and then in the second equation I've got 1x and positive 2y. And then what I'm going to have is something called a vector, but in this case you can think of it as a column matrix that has the letters x and y in it. And then over here I've got my resultant vector, which actually is just another type of matrix, which is just the constants from this equation. So all I've done at this point is convert this equation, this system of equations rather, into a matrix equation. Now, in order to solve this system, what I need to do is find the inverse of this matrix. So we're going to use the finding an inverse process that we learned just a minute ago. So I'm going to use a scrap piece of paper to do that calculation on. Okay, so I'm looking for the inverse matrix of 4, negative 1, 1, 2. Okay, so the first step is to find the determinant of that matrix. So 4 times 2 is 8, minus negative 1 times 1 is negative 1, so 8 minus negative 1 is 9. So since the determinant is not 0, I know that there is an inverse. And then what I do to find the inverse, if you want to call this matrix A, then the inverse of A is 1 over the determinant that we just calculated, so 1 over 9, times a modified version of the original matrix. So again, just like before, we flip-flop the entries on the downward diagonal, and we negate the entries on the upward diagonal. Okay, so that is the inverse of matrix A. Alright, here's what I'm going to do back in my original problem. I'm going to multiply that inverse of matrix A on both sides of this matrix equation. So I'm going to multiply 1/9, 2, 1, negative 1, 4, times all of the stuff that was on the left-hand side originally. And then, since this is math, and whatever you do to the left-hand side of the equation you have to do to the right, I have to multiply by 1/9, 2, 1, negative 1, 4 over here as well. Okay, so all I'm doing is sliding that inverse matrix in. So now I can get rid of my scrap paper, it served its purpose, and now we move on. Okay, the nice thing about matrices is that you can multiply them associatively, which means if you have more than 2 matrices in a row, you could do the first 2 together or the last 2 together, doesn't matter which pair you do first. So I'm going to choose to multiply these 2 matrices together first, and you'll see what happens is very nice, and that's the reason we're doing this in the first place. Okay, in this case, what we're going to do is multiply this row times this column, just like we learned in an earlier section. So 2 times 4 is 8, plus 1 times 1, so we've got 8 plus 1, which is 9. Then this row times this column. Well, 2 times negative 1 is negative 2, and then 1 times 2 is positive 2. Add those together, negative 2 plus positive 2 is 0. Then this row times this column, so negative 1 times 4 is negative 4, plus 4 times 1, which is 4, so negative 4 plus 4 is 0. And then I've got this row times this column. Negative 1 times negative 1 is 1, and then 4 times 2 is 8. 1 plus 8 is 9. Okay, so I multiplied that out. Well, notice that in this matrix now, everything in here I can multiply through by 1/9, and it'll come out very nicely. In fact, it gives us something called the identity matrix. And that's the whole point of these inverse matrices, is that when you multiply a matrix by its inverse, you end up with the identity matrix, which the beautiful thing about that is if you multiply these two things together now, 1, 0 times xy. So 1 times x is x, 0 times y is 0, add them together and you get x. Then this bottom row times this, 0 times x is 0, plus 1 times y is y. So notice the identity matrix is kind of like multiplying a number by 1. It doesn't change the other part. So if I do all of the math on this side then, that will give me the answer to this system of equations we were given. Alright, so let's do the multiplication on the other side of the problem then. Alright, so 2, 1, this row, times this column. Well, 2 times 1 is 2. 1 times 7 is 7. 2 plus 7 is what goes here. Then this row times this column. -1 times 1 is -1. 4 times 7 is 28. Now simplify inside of that matrix by adding. So 2 plus 7 is 9. -1 plus 28 is 27. And then this is a scalar, so multiply each entry by 1/9. Well, 1/9 times 9 is 1, and 1/9 times 27 is 3. So then we see then that our solution is the ordered pair 1, 3. X is equal to 1, y is equal to 3.